Okay, so in our first video for this section, we talked a little bit about the volume of a cake. So here's the problem. A new bakery offers decorated sheet cakes for children's birthday parties and other special occasions. The bakery wants the volume of a small cake to be 351 cubic inches. The cake is in the shape of a rectangular solid. So that's like a box. Let's see. They want the length of the cake to be 4 inches longer than the width. So let's call the width W, and the length is going to be W plus 4, because it's 4 inches longer than the width. And the height of the cake to be 1/3 of the width. So it's going to be 1/3 W for the height. What should the dimensions of the cake pan be? So volume of a rectangular solid is length times width times height. Our length is W plus 4. Our width is the width. And then the height is 1/3 W. And that's the volume in terms of W. But we want this to equal 351. Okay, we want the volume to be 351. So let me do some rearranging here. I'm going to make it 1/3 W squared times W plus 4, equals 351. Let me erase the 1 equal sign. Okay, so if I distribute, you know what, before I distribute, I'm going to multiply both sides by 3 because I'm not a real fan of that fraction in there for what I'm going to be working with. And it's an equation I'm trying to solve, so I can do that. And I get, 1053. All right, so if I distribute, I get W cubed plus 4W squared equals 1053. But what we're going to do, this is a polynomial equation that we're trying to solve. And so we're going to bring over that 1053. Now, one thing I was going to mention, let me go back a minute. We're setting it to 0. You might be saying, well, it was factored up here. Why didn't you just use the zero product principle? I can't because it's not set to 0. So then you could say, okay, well, how about if you factor here? Yeah, that's not really going to factor, so that would be a problem. Okay, so this is the polynomial I have, and I'm going to try to find zeros for it. Now, I can use the rational zero theorem. So let's see, where do I want to put that? Rational zero theorem. So P's over Q. So factors of 1053, and I'll have to figure what that is. And then this is just a 1, right? Okay, so over 1. I know 3 goes into 1053 because that's how I got it, 3 times 351. If I add up the digits of 351, it's 9, so I know 9 goes into it. Let's see, how many times does 9 go in? Oh, 39. So I'm getting there. 3 times 9, which I could split that 9 into 3 times 3. And then this would be 3 times 13. So a 13 will go in, and then different combinations of 3, like 3 squared, 3 cubed, 3 to the 4th power, 3 to the 5th power. Nope, just 3 to the 4th power. Okay, so those are ones that I can try. I'm looking for the width, so I don't have to try any negative ones because I'm not going to have a negative width. All right. Oh, and also 1, right? Like we always talk about 1 being a factor. Well, and we usually try 1 first, so let's try 1. Now, I'm going to need the coefficients off here. I'm going to need a 1, a 4, a 0, and a negative 1053. And what I'm looking for is for my remainder to be 0 so that I find the 0. Okay, bring down the 1, 1 times 1, 4 and 1 is 5, 5 and 0 is 5. Yeah, this isn't going to be close. So it's going to be like negative 1048 or something, like way off. Okay, so 1 didn't work. Let's try 3. Again, I don't have to try any negative numbers here. Okay, 1, 3, 7, 21, 21. 21 times that is what, 63? So I'm getting closer. So it's like 990. I'm going to make sure that's right. Yeah, that looks right. Okay, I'm getting closer. So what's my next factor of 3? Because look at what I have for factors. I've got 3. This is 3, right? I've got 3 times 3 times 3 times 3 times 13. So 9 might go in, 27 might go in, 81 might go in. I can try the 13, but I'm going to try 9. Now what am I trying 9 in? Well, those same coefficients. Okay, 1 times 9, 13. 13 times 9. So 7. I think it's 117. Okay, what's 9 times 117? I didn't bring a calculator, so 3, 6, 5. Oh, this is looking promising. 1053. Okay, great. So that's going to be 0. So I found a 0. I found 9. Let's see, what does 117 break down into? 117 is 9 times 23. Let me make sure I did that right. Yeah. Okay, and 23 is prime. Ooh, not 23, 13. Sorry about that. Okay, we knew it had to be a 13 anyway. So my other choice would be 9 or 13. I could see if 13 goes in. I don't think it's going to. But I'm happy with the answer 9. When you try the 13, if you wanted to try it, you can do it right from there. I don't think this is going to factor though, because 9 times 13, I'm not going to get a 13 in the middle, like that's a quadratic, so I wouldn't even bother doing this. Now, does it mean there are zeros? Yeah, but they're not going to be rational. And so, we're measuring cake, so we kind of need it like in terms of inches here. All right, but 9 works, and so we can use that. So what does it mean? Well, it means my cake here has a width of 9, and then this was going to be 9 plus 4, or 13 for the length, and then 1/3 of 9 is going to be the height. So I'm going to get dimensions. It's going to be 3. It's going to be 3 inches by 9 inches by 13 inches. Those would be the dimensions of the cake. Okay? Maybe 13 did go in. Anyway, there you go.